Dear colleagues, it's time to our next session, the Brazilian session, and I hand the floor over to our chair, Marcela Canillo. Marcela, can you hear me?
Yes. Can you hear me?
Yeah.
Nice. Well, greetings to everybody. It's a pleasure to be here, an honor for us to be part of this online event. We thanks Anna and Olga for the organization and the kind invitation to be part of this very nice event. I also like to extend my greetings to Professor Elena Dragalina, head of LLFP. We have, as you know, an agreement, a research agreement between the Center for Logic of Unicampi and LLFP of AHSE from some few years ago, and this is part of this collaboration between both institutes. We will start this, let's say, Brazilian part of the event by inviting to talk now to Henrique Antunes and Newton Peron, my colleagues of mine. They will they will make a joint presentation divided in two parts, let's say, in which they will present two works on the subject of logic and fiction. On the first part, Enrique will talk about a joint paper with Newton, which is already published and available online. And on the second part, Newton will speak about work still in progress between Enrique, Newton, and I, which is related with the ideas of Ivlev, which is interesting, I think, to the Russian side. Then thank you, Enrique and Newton, to be here. And then please, Enrique, you can start with your talk. The idea we decide to make the two talks one after the other, and then the questions for both talks will be made at the end of the Newton's presentation. Then Enrique, please, you can start. Thank you.
Greetings, everyone. Can you hear me? Are you
Yes.
able to hear me? Yeah, is it okay? Okay. So greetings, everyone. Thank you, Marcelo, for the introduction. Thank you, Anna, Olga, Elena, for organizing this conference and for the invitation. I'm gonna share my slides here. So let me. Okay. Are you able to see the slides? Okay, thanks. Okay, as Marcelo said, we're gonna divide our talk in two parts. The first part, where I'm gonna talk about the results in a paper we published in 2022 in Logic and Logical Philosophy. And then there is a lot of work to be done. And then Newton is gonna talk about our joint work with Marcelo on non-deterministic semantics, which kind of is a development of this simple framework I'm going to talk about. So the results in this that I'm going to talk about in this talk is a kind of stepping stone for the development of a more of a logic of fiction. So we're going to start with the four-valued logical framework. It's not actually a single logic. There are several logics. And we start off with the brute intuition. Consider, for example, these two sentences. Sherlock Holmes is a detective, and Dave Toschi, who is the primary investigator in the Zodiac killer case, is a detective. The brute intuition of our that guided the development of our logics is that both sentences are true, but while the first one is fictionally true, There is true according to some pieces of fiction, what is told in some, depicted in some pieces of fiction. The second one is factually true. It's true according to how the world somehow is. And we want to take this intuition, this brute intuition, seriously in the development of our logical framework. And so we're going to say that there are two kinds of truth and falsity. We have factual truth, factual falsity, and fictional truth and fictional falsity as well. So the question is how to develop a logical theory that is supposed to model reasoning about fictional and non-fictional objects. There is reasoning involving statements about both kinds of objects. So the problem here is that we want a logical framework that countenances both fictional and non-fictional individuals, and also fictional and non-fictional statements. And so we want to deal with mixed statements such as Sherlock Holmes and Dave Toschi are detectives, or Dave Toschi admires Sherlock Holmes, or any real detective knows more forensic science than Sherlock Holmes did or does. So the problem here is kind of reminiscent of a classical problem in the philosophy of mathematics, which is for a nominalist like Hartrfield. How are you supposed to account for the occurrences of mathematics in the natural sciences, for instance? I mean, if you take a fictionalist instance with respect to mathematics and mathematical discourse, you want to deal with these mixed contexts that, like applied mathematics or scientific theories. So this is the main problem we're trying to deal here. So our initial proposal is that a sentence alpha gets assigned either a factual or a fictional truth value depending on several aspects. If alpha contains occurrences of fictional terms, that will determine whether alpha has a factual or a fictional truth value. Also, the subformulas of alpha, the values of those subformulas will also determine whether alpha receives a factual or a fictional truth value. And if alpha is a general formula, then its instances, the truth values of its instances are also be important here, okay? So in the paper I mentioned before, which was published in 2022, we developed two four-value logics, L1 and L2, and whose design was guided by that brute intuition I mentioned before. And there could be also other logics, but these are kind of examples or instances of this general logical framework. By tweaking some details in the logics, we could obtain variations on L1 and L2. But the main difference between L1 and L2 concerns how the mixed statements or mixed contexts are evaluated. So in the first logic, fictional terms and fictional truth values take precedence over factual ones. So we'll see what this means in the next slides. And while in L2, factual terms and truth values take precedence over fictional ones, okay? So these results, as well as some suggestions that Newton will discuss in the second half of the talk, are published in this paper. Here's the reference. So what is the plan? My part of the talk is divided up in two main parts. So first of all, I'll give a kind of informal or semi-formal presentation of the ingredients of these logics, okay? So I'll talk about these factual and fictional truth values, atomic formulas, how they are evaluated in either logic. We'll see that these logics also have a Schrick operator, which is a kind of actuality operator, and also they have a logical predicate, an existence predicate. And afterwards, I'm going to talk in more detail about the formal development, so the syntax, semantics, and the natural deduction systems that we came up with in that work, okay? So the ingredients, as I said before, our semantics or our four-valued semantic framework countenances four truth values, The uppercase T and F stand for factual truth and factual falsity, while the lowercase letters T and F stand for fictional true and fictional falsity. Okay, so for example, 1 and 2 they would be evaluated in this way. So the first sentence would receive the value small t. I'll use these expressions and big T, so it's easier for me to express myself this way. While the second sentence it receives the value big T. Okay. And the negations of these sentences they behave according to the following table. So negation in these two logics behave as expected. So negation toggles between true and false, truth and falsity, depending on whether the values are factual or fictional. Okay. So far, so good. The problem is, how are you supposed to interpret binary logical operators such as conjunction or disjunction? And the problem is that we may have two formulas, alpha and beta, such that alpha has a factual truth value, while beta has a fictional truth value. And the question is, how are you supposed to assign a truth value to their conjunction? I mean, is it supposed to be factually true or fictionally true? So consider, for instance, sentence 3, Sherlock Holmes and Dave Toschi are detectives. We know the first conjunct is fictionally true, while the second is factually true. What should be the value of 3? Is it supposed to be factually true or merely fictionally true? So here comes the divide between the two logics. So because the first logic, according to the first logic, this sentence is going to be fictionally true, okay? While according to the second logic, this sentence is going to be factually true. So as I said before, in the first logic, fictional truth values take precedence over the factual ones. So this divide, it shows up for every connective except for negation. So conjunction, disjunction, and so on and so forth, and also for the quantifiers. And also, they manifest themselves, the difference manifests themselves with respect to predicates as well, okay? So according to the first interpretations, the four truth values are ordered in the following way. So here's the extremes are the factual truth values, while we have the fictional truth values in the middle of the order. And taking conjunction to be the minimum between the values of the conjuncts, we then have the following truth table. So here we see that if one of the conjuncts is fictionally true, no matter the value of whether the second conjunct is factually true or fictionally true, it will receive the value, the fictional value, okay? And something, the opposite occurs with respect to the falsity situation, okay? So according to this interpretation, Sherlock Holmes and Dave Toschi, although this sentence is true, it's merely fictionally true, okay? Now, the second interpretation takes a different approach. So we have here this order. And so whenever you have a factual truth value T, then the conjunction is going to be factual as well. So this occurs in these two cells. Whereas if we have the occurrence of a fictionally false conjunct, then the conjunction will be fictionally false. So according to this interpretation, Sherlock Holmes and Dave Toschi are detectives is going to be factually true, okay? Because now, again, in the second interpretation, factual truth values take precedence over fictional ones in this way. So we also have tables for disjunction as well. So the behavior is similar. Disjunction is just a maximum of the values of the disjuncts. And here are some examples of how these two interpretations work. Okay, so for example, either Sherlock Holmes is a detective, which is fictionally true, or Dave Toschi is a detective, which is factually true. So in the first interpretation, this disjunction will receive a factual truth value, while in the second interpretation, it will receive a fictional truth value. Okay. Sherlock Holmes and Dave Toschi are physicians. Both of these sentences are false, but since Dave Toschi is a physician, is factually false, this is gonna get receive the value of big F in the first interpretation and small f in the second interpretation. Okay, so enough for the logical operators. As I said before, these differences also manifest themselves at the atomic level. Okay, so if we consider atomic sentence such as David Toschi admires Sherlock Holmes, we could ask ourselves if this sentence is fictionally true because it concerns a fictional character, or is factually true or false because it says something about a real individual. And as we done in the case of the logical operators, we could interpret this sentence in two ways. I mean, the first way, the first interpretation says that if there is an occurrence of a fictional term or a fictional name in an atomic sentence, then that sentence must have a fictional truth value. So according to this interpretation, sentence 4 or its formal counterpart would be either fictionally true or fictionally false. While in the second interpretation, if a real or non-fictional term occurs in atomic formula, then its value should be either factually true or factually false. So here there is something, we try to present these logics in a very uniform way so that the behavior we identified with respect to the connectives and quantifiers also extend to the atomic formulas. But I would say that this is not mandatory. I mean, we could, in a further development of this logic, adopt specific semantic clauses for each predicate. So for example, I would say that our intuition in this case is that 4 would receive a factual truth value. And so we would interpret this predicate according to which if the first place of the predicate is a non-fictional term, then it should receive a factual truth value, while if the first place of this predicate is a fictional term, then we would evaluate it as either fictionally true or fictionally false. So take notice that this interpretation of the predicates could be improved in this way, right? So how are predicates? How does the semantics work now? Here's a informal or semi-formal presentation of semantics. So we have dual domain models, like some presentations of free logics. And the first model, DR, is the domain of real individuals, so the ones that are supposed to be non-fictional, while the second model, domain, DF, contains the fictional individuals. These two domains are disjoint. And also we have an interpretation function that assigns items constructed over the union of the two domains to the non-logical symbols of the language. And one important aspect of this interpretation is that both individual constants are interpreted as elements of the union of the two domains, and predicate letters are interpreted over the union of the two domains. So this means that a predicate letter may include both real and fictional detectives. So it cuts across both domains, right? So how does the interpretation work? The interpretations work in logics L1 and L2. So a formula such as, let's consider a binary predicate P, two individual constants A and B. So this formula, this atomic formula is going to be factually true if the pair AB belongs to the extension of P, and both individuals belong to the real domain. Okay, so I'm being a little sloppy here, so because I'm not indicating the interpretation of these constants, but I'm going to be more rigorous in a while. And also, this formula in the first interpretation is factually false if the pair does not belong to the extension of P, but both terms or their interpretations belong to the real domain. While the formula is going to receive a fictional truth value, either T or F, if at least one of the terms or their interpretations belong to the fictional domain, right? So in the second interpretation, the situation is quite the opposite because an atomic formula will receive a factual truth value if either one of the terms or the other belongs to the real domain, while it will receive a fictional truth value only if both terms belong to the fictional domain. So again, here we have the idea that fictional terms take precedence over non-fictional terms, and here we have the opposite situation, right? Okay, so another ingredient in our framework is that we extend the language of classical first-order logic, so a language that has negation and conjunction and disjunction and so on and so forth, quantifiers, identity, etc., with a shriek operator that is supposed to express whether a sentence is factual or merely fictional. So this operator, when preceded to a formula, says that the sentence in question, sentence alpha, is factual. Okay, so by means of this operator, we can, within the object language itself, express something like alpha is factually true, which would be expressed by this conjunction, alpha and shriek alpha, or alpha is factually false, so not alpha and shriek alpha. And also alpha is fictionally true, alpha, and not shriek alpha, and alpha is fictionally false, not alpha, and not shriek alpha. So by means of this operator, we can express something like it is fictionally true that Sherlock Holmes is a detective by means of the conjunction DS and not shriek DS. Or it's factually true that David Tosh is a detective by DD and shriek DD. Okay? This operator behaves in a quite natural way. If the formula alpha has one of the factual truth values, either T or F, then the shriek alpha will receive the value T. Whereas in the fictional case, the formula will receive the value factual false. Okay, so this formula here, it does not have a fictional truth value. A quick side note: this operator it has some resemblances with the operators, classicality or consistency operators of the logics of formal inconsistency, which have been investigated in the Brazilian school. Marcelo is one of the primary investigators of these logics because it has this, this role of internalizing within the object language itself a notion that is primarily meta-theoretical. Okay. And there are also some issues that we like to investigate in the future concerning inconsistencies and truth value gaps and truth value gluts in fiction, because we could take in this framework this operator as a kind of classicality operator, in the sense that, factual truth values do not admit of truth value gaps or truth value gluts, while fictional truth values do, right? So the last ingredient of our approach is the existence predicate, which is supposed to indicate whether a term is a name or stands for a real individual, a fictional individual, or a fictional one. So if you consider Sherlock Holmes exists, we acknowledge that there is an ambiguity in this sentence because it may be taken as expressing that Sherlock Holmes is a real person, which is false. But it can also be taken as expressing that Sherlock Holmes exists as a fictional character or exists within the story. And so we are able to express these two readings of this sentence in the following way. So this first conjunct is actually logically true in both logics, but we may express this as saying shriek exists X such that X equals S, which means that Sherlock Holmes is a real person, is a non-fictional object. But we may also express the second reading as saying that Sherlock Holmes is not shriek, there is X such that X equals S. So you see that our interpretation of the existential quantifier is according to our interpretation, the existential quantifier does not carry ontological commitment to non-fictional objects because the quantifiers, they range over the entire domain, both the fictional and real domain. And also, we are non-committal about the ontology of these objects here. So someone could take this quantifier as expressing the existence of some object, abstract object, for instance. And in order to express the fact that a certain term is non-fictional, we introduce in our language an existence predicate, which is, of course, reminiscent of free logics, which is interpreted according to the following rules. So a sentence like EA is factually true if A is interpreted as an element of the real domain, and the sentence is factually false if the term is interpreted as an element of the fictional domain. Okay, so enough for the informal presentation. So we're gonna present now how we developed these ideas formally. Our logics, they have the following logical vocabulary. So negation, sorry, it should be conjunction here. Conjunction in the shriek operator, universal quantifier, individual variables, and logical predicates such as identity and the existence predicate, and also parentheses. And we will specify a first-order language by means of a triple CFP, such that C is the set of individual constants of the language, F is the set of function symbols, and P is the set of predicate letters. Pretty standard here. And also, we're gonna define the other connectives, disjunction, or material implication, or B implication, and also the existential quantifier in the usual way, right? So this it's easier to deal with the logic with this kind of minimal language. The semantics of these logics, as I said before, it's a triple with two domains, two disjoint domains, and so the real and the fictional domain, their union is non-empty, they are disjoint. And the interpretation function assigns an element of the union of the two domains to each individual constants, a function to each, a function in the global domain to each function letter, and also a subset of Dn to each predicate letter. The existence predicate is interpreted as the real domain, and identity is interpreted as identity in the global domain. And in our presentation of these logics, we adopted an objectual semantics, so we work also with assignments. As usual, an assignment is a function from the set of variables of the language to the global domain. Okay, and also we'll use this notation here to indicate that an assignment that is exactly like S, but it assigns the individual A to the variable X, right? So it's something like an X variant of the assignment. So the semantic clauses for these logics, we take, first of all, S of tau as the denotation of tau in the model M and in the assignment S. This is usually defined inductively in the usual way, and use this notation to indicate the truth value of alpha in the model M and assignment S. Okay, so here's a generalization of what I said before. P1 stands for the semantic clauses in the first logic. P2 stands for the semantic clauses in the second logic. So an atomic formula in the first logic will receive the value factual truth if the n-tuple of interpretations of the terms belongs to the interpretation of the predicate letter, and also all the terms, all the interpretations of the terms, the denotation of the terms, belong to the real domain. This is also a condition for an atomic formula to receive the factual value f. But this time, the any tuple does not belong to the interpretation, the extension of the predicate letter. As for the fictional truth values, the any tuple belongs to, in order for a formula to receive the fictional truth value t, the any tuple belongs to the extension of the predicate, but there is at least one term whose interpretation belongs to the fictional domain. And the same applies to the case of fictional false. In the second logic, we have the opposite situation, because a formula will receive one of the true truth values, t or f, if a condition for this to happen is that the interpretation of at least one of the terms that occur in the formula belong to the real domain. So here again, real individuals take precedence over fictional ones. And in order for a formula to receive the fictional truth values, all terms that occur in the formula must be interpreted as fictional individuals. As I said before, the existence predicate is interpreted in this way. An atomic formula Et tau receives the value factual truth if the interpretation of t belongs to a real domain, and it receives the value factual falsity if the interpretation of the term belongs to the fictional domain. And here we have the truth tables we encountered before. As for the quantifiers, they're interpreted along the same lines as conjunction. So in the first interpretation, a universal formula for every x alpha will receive the value t if all instances of alpha receive the value t for every individual in the global domain. Whereas a formula will receive the value fictional true, fictional t, if all its instances are true, none is false, but at least one of its instances is fictionally true, right? The formula will receive the value fictional false if none of its instances is factually false, but at least one of its instances is fictionally false. And the formula, universal formula, will receive the value factional true, false, if at least one of its instances is factually false. In the second logic, the situation is quite the opposite, as you might expect. So a formula will receive the value fictional truth if all its instances are fictionally true. And it will receive the value fictionally false if at least one of its instances is fictionally false. And a similar situation goes for the factual truth values. So this formula receives the value big T if it's not false. Any instances, there are no false instances, but at least one instance is factually false, factually true, sorry. And it will receive the value factually false if none of its instances is fictionally false, but at least one of these instances is factually false, right? And we define the semantic consequence relation in terms of preservation of true. The designated values, there are two designated values, which are both factual true and fictional truth. Okay. In our paper, joint paper, Newton and I also came up with natural deduction systems, which are both sound and complete with respect to the corresponding semantics. The systems are obtained by taking classical logic, a set of rules for classical logic, and adding these rules that you see here. They're specific, they govern the behavior of the shriek operator and also the existence predicate. For example, in the first system, we can also always infer that any existence sentence, such as this one, is either factually or fictionally true. Okay? And also, we may infer from the fact that a certain atomic formula is either fictionally true or fictionally false, that each of these of its terms are existent. I won't go through all the rules. I don't want to be boring here, but I just want to indicate some of the rules, their rationale. For example, this rule says that if alpha and beta have factual truth values, then their conjunction have a factual truth value as well. While these rules here say that if a formula, notice that this expresses that alpha is factually false, right? So these rules here tell us that if alpha or beta is factually false, then their conjunction has a factual truth value. And so on and so forth for the other rules. For example, this rule here says that if every instance of a formula is factual or has a factual truth value, then the general formula is also factual. And this rule here says that if there is an instance of alpha which is factually false, then for every x, alpha is either factually true or factually false. Actually, it is factually false. We can use the classical logical rules to get the conjunction here. And so on and so forth. There is a small detail in this rule here, the second rule. The predicate letter P cannot be replaced by the existence predicate. And the reason is quite obvious, because we would be able to infer by this rule E tau, and then applying this rule here, we obtain that tau exists. So if we allowed P to be replaced with E here, we would be able to infer that every term exists, which would actually collapse the system into classical logic, right? Also, the system N2, for the system for the second logic is a little bit different. I mean, the main differences here are, for example, that if an atomic formula is factually evaluated, then at least one of its terms exists. And these rules here, for instance, say that if in a conjunction, if alpha holds, either it's fictionally true or factually true, and one of the other conjunct is factual, then the conjunction is factual as well, right? So the same restriction applies here as we saw before. Okay. As I said, both systems are sound and complete with respect to the corresponding semantics. And also we have some interesting properties concerning these two logics. The first of this property is if every term, everything exists, then every formula is factual. Okay, so if we are only talking about non-fictional objects, then every formula will receive a factual truth value. On the other hand, if everything we are talking about is non-fictional, then every formula alpha in which the existence predicate does not occur will be fictional, which is expressed by this formula. And clearly, both logics are conservative extensions of classical logic. Okay. Oh, there is another result here as well. It's a kind of recovery or mapping of the classical inferences in each of these logics. For example, if in classical logic alpha can be deduced from gamma, then the conjunction alpha and factual alpha can be deduced from gamma, together with the additional premise that everything exists. And the conjunction alpha and fictional alpha, not trig alpha, can be deduced from the premise that nothing exists. And as I was saying before, both logics are conservative extensions of classical logic. Okay, so just a few words about this framework. This is a very simple framework. It's a deterministic semantics, a four-valued semantics. We actually presented two logics, but as I said before, we could have by tweaking the semantic clauses, we could have more logics, like having mixing the semantic clauses for a conjunction of one logic with the semantic clauses for disjunction of the other. So there are other possibilities, but we think that these two logics are the most natural ones. And the idea of our research, Newton will talk about this in a while, is that by this departing from this stepping stone, the simple logic, we're going to try to develop a more complex framework which is perhaps more suited to account for fictional contexts of reasoning, right? So thank you for your attention. That's it.
Thank you very much, Enrique. Well, as I talked to you, you prefer to have questions after Newton talk, or you you prefer in this way?
I'm okay if someone wants to ask questions now. There's no problem. So whatever you think appropriate.
Okay, I don't know, Anna, what you prefer. We can continue with Newton, or he's not connected.
Oh.
Yes.
I think we can continue with Newton.
Okay.
I ask you to wait 1 minute because we have some technical problems.
Okay. Okay.
Yes, we are ready to continue.
Okay, thank you, Anna. Well, Newton, then you can start with your talk. Your microphone is
Now,
yes.
are you seeing? Are you okay? Are you seeing the slides? Are you hearing me?
Yes, here. See.
Can you hear me? Yeah. Okay. Yeah. So, thank you, Marcelo, and thank you, Anna, for the invitation. Well, I I think I will talk shortly. Here we have some ideas that me, Henrique, and Marcelo are trying to expose it to you that may be interesting. They are some developments, and here I will focus on evil idea in model logic that you can see that we have a very near approach, because we have 4 values, 2 designated values, and we had at the first framework we had 2 logic, and here I'm trying to make a semantics more easy to deal with the 2 scenarios at the same time. Okay, that's the idea. The point is that we can start with the compositionality principle that is expressed by Frege, that, well, if you have a sentence like Odisseo was set ashore at Ithaca while sound asleep, with a fictional term, according to Frege, that sentence has sense but not reference. Okay, so that's the we can say the orthodox Fregean view of the way that fictional terms may be related to true values in a logical framework. So that's why Lemon proposed this logic called NINO. Okay, no input, no output. The ideas here that, well, you have true value of a sentence is the function of the reference. So if there is no input to an operator, we can't have an output. So in formal terms, it means that if a term do not refer to individual, the sentence lacks true value. Okay, so it's the idea to model in a formal way the Fregean notion of, well, in a sentence, if a term has no reference So the reference of the sentence that is a true value will not exist. But we have some unorthodox view that will see to the notion that well, in fact, when we talk about fictional names, we are think of mock prop names. So it's a kind of name of something. It's something that really does not exist, but it's a name of something. Okay, so it has sense because it's the sense of the name of something. That's an interpretation that it's even one, that, well, if the sense is a mode of presentation of reference, so there's some kind of reference in when we were using a fictional names, not a real reference. The fictional one, it does not exist, but there is a kind of mode of presentation of something anyway. Architect name, prop names are fictional prop names, and semantical levels we have factual object and feature object. That was what Henrique showed it to you. And in some of the logic, I think L1, if I remember, if one term occurs in a tongue sentence, it will receive a fictional true or a fictional false value. Okay, so that is what we have in one of those logics for atomic sentence. So if we see the example, the Frege example, Odysseus land in Ithaca. So we have the Frege principle of computationality here that works like, well, with those clauses. Okay, so if at least one term is fictional, the value will be fictional. So here we have one term fictional for some term. Here we have the same thing, and now we're sure that the term is the sentence, the atomic sentence, will have a fictional value. Well, that is a little formal model. So here we have Odysseus as the reference of O, Ithaca the reference of I, and Ithaca is a real island, but Odysseus is not a real person. And here we have the value will receive a fictional value. It's true, but it's fictional. Well, but how we deal with non-atomic sentence, you know, because it's not an orthodox interpretation of Frege. So I think, of course, we can say now, if you have at least one fictional value, the sentence will be fictional, but I'm not so sure that it's the only way to see how we extend this non-orthodox way to understand Frege principle of computationality that was focused on atomic sentence. So the another way is, as I said, merge those logics. So that's its idea, to use non-determinants or quasi matrix, Evlev Quasi matrix, to these ideas. So to those logics that, so it's a kind of fusion of those logics, you know. I mean, when we have mixed values, we are not sure what kind of values we should use to be the result of the combination of the operator. Okay. So when they are the same one, it's clear, okay, because it's a designate. So conjunction with both designate value will receive a designate value, and it's if both are factor, the value is factor. If both are fictional, the value is fictional. But when we have mixed case, we're not so sure. What we know that the two designate values, if we are dealing with classical framework, it will be designated, but which one? We don't know. I think that is why we develop two logic, because we don't know. It's not so clear which path we should take. Okay, so that's the same idea for disjunction, etc. Okay, so that is the non-determinate scenarios for conjunction and for disjunction. So the operators will be analogous. So if we are talking about generalization, okay, of sentence that all are factor true, so the universal will be factor true. And the same thing for fictional true. So if each particular instance is fictional true, the universal of the sentence will be fictional true. And if we have this scenario, so the scenario that we have all are designated, but we have one factor true and at least one fictional true, and all instances are designated. So here we have this non-determinate scenarios. And in fact, we do the same thing that we did to propositional operators to the quantifier. We're merging the universal of the first interpretation and the universal of the second interpretation. And that's the same thing that we'll do to the false, right? So all are, we say, well, at least all are designated, all are factor, but at least one false, it's the universal will be false. If all the values are fictional and at least one is fictionally false, the value will be false of the universal. But we have a mixed scenarios like that, okay? So we have at least one fictional and one factually. So it's received a set of possible non-designated values. Okay. So here we have just some formal definitions. You know, in first order non-determinate semantics, the variance, the bound variance. I mean, if you take a formula and another formula that we only change the variables, we must force that we don't lose the values of those variants. So in semantics way, we must add this clause, okay, to some technical results that are important to correct this. So from a natural deduction point of view, the difference here from atomic level is what we we have here, that is the Frege principle of computationality, okay? I mean, if a term is it will be will receive a factorial value if and only if every term that occur in a atomic sentence is factual, okay? It exists. And if you see, we have here less rules for conjunction and disjunction, because we all know that, well, if both are factual, the value is factual. If both are fictional, the value of conjunction and the disjunction is fictional. But we do not say and think about the combination because it's not deterministic. Of course, it's an extension of classical logic. So we know that if we have a sentence that has a designated value and another sense designated conjunction will be designated, but that is because of the rules of classical logic, okay? It's an extension of classical logic in the same way that evil systems are extension of classical logic too. That's the same idea to the universal. So we have less rules here because we have more semantic scenarios, okay? Semantic models. But maybe we want to be more free, you know? I mean, the Frege principle for atomic sentence maybe is not so interesting, and in fact, I will show some reason why we think that maybe it's a visual example that Frege used here. But if we abandon Frege principle, we say from any predicate letter something very general, okay? We won't say that, well, if all terms are factual, the value will be factual. If all, so that's the first and the last scenarios here. And the second and the third clause, we are dealing with terms that all are fictional, so the value is fiction. That's clear. That's the kind of sentence that, well, we know that fiction, that we all have fictional terms like, I don't know, Sherlock Holmes loves Watson. So we have two fictional characters, so it's clear that we are in the fictional domain. And if we're talking about two real persons, we are in the real domain, so that's clear. And we have, for any predicate letters, we have those rules, okay? They are quite simple. If all terms exist, we're talking about real values. If all terms do not exist, we're talking about fictional values, okay? But here I'm showing some examples with two verbs that maybe has the key to open this box. So the example of Frege is land. Okay, so here we have two examples of fictional and factual terms. So also land analytica, that's Frege example. We're using a fictional term and a factual one. And Barack Obama land analytica, we are talking about two factual terms. Okay, we talk about real things. So here is clear that we are in the fictional domain and we are the factual domain. But if you see the admirers, it's quite interesting because, for instance, Barack Obama said that he admired Spider-Man. So is that fictional? It means that's factual. There's something about Barack Obama. So, but in the same way, if I say I admired Spider-Man, that's fictional, false, of course. But it's fictional, okay? So it seems that the Frege principle here is weird, no? We're talking about real things here, no? And admiration, real admiration, I think. So from the global perspective, I mean, the clause that we said that will be held for any propositional letters, we can evaluate the third and the fourth examples. Okay, here they are clear false. Okay, because we are using the same domain in the third and in the fourth sentence. The third is talking about fictional things, and the fourth talk about factual things. Okay, that's a formal model for that. I will, that's clear, no? It's the same thing. So it can be recommended that they are real, Odisseo and Spider-Man, they are fictional. So we cannot evaluate the first and the second forms. Okay, they have no truth well. But the idea here is, well, we can add some rules, so semantical clause and deduction rules for a specific predicate. Okay, so for the L letter, we have a semantic that is semantics of the verb to land. I mean, land, it seems that it behaves like a Frege principle of compassionality. So requires that the agent and the location are real. Okay, so if at least one term in force, the semantic of lands is fictional, the sentence we'll talk about the fictional thing. Okay, if you say that Barack Obama landed on the island of Peter Pan, so it's fictional. Okay, it's not factual. It's impossible. But this confirms Frege principle, and this specific case, I don't think that's the same thing to admire. Okay, as Henrique said, admirers depends on the subject terms. If the subject is factual, we're talking about something factual. So Barack Obama admires Spider-Man. That's factually true. In the same way that Albert Einstein admires Marie Curie, it's true. Okay, he said that it's true. But if you're saying that also admires Spider-Man or Harry Potter admires Dumbledore, we talk about fiction. Okay, it's the first also is false, the second is true, but we talk about fictional sentence. Okay, so the semantics of L in this example will be like that. Okay, so if it's respected Freudian compositionality principle, okay? But the semantics of A is quite different. The same, the first term that you say that the sentence is factional true or fictional true, factional false or fictional false, okay? So here we have, and the first one is fictional true because the first term is from a factor domain. The second is fictional true because the second term is on the fictional domain, and the same thing for the non-designated values, okay? So in this case, we can evaluate all the sentences, okay? So here we say that, well, also landed on Ithaca is fictional true, but Barack Obama admired Superman is factually true because of the semantic of each particular layer, okay? Letter. So from a deduction point of view, we add to those general rules, specific rules, okay? So from L1, if the first term is not real, we're talking about not real values, okay? And if the second term is not real, we are talking also about non-real values. But from the A point of view, the point of view of the predicate, the A predicate, it's different. It's the first term that you say that if the atomic sentence is real or factual or fictional, sorry. So the first one is fictional because the first term exists, but the second is, the first is factual because the first term exists, and the second is fictional because the first term does not exist. Something that does not exist cannot admirize from a factual point of view something that exists. Can admirize in fiction, but not in the real world. But something that exists can admire, and in the real world, something that does not exist. That's the idea. Well, that's the reference of our work. So it's the list of reference that me and Henrique use it, okay? We have here some works, that's the works of Coniglio about evolute model logics. We have to the average, the events interpretation, Frege works, brilliant works. That's the Ivlev, the important Ivlev article that I studied during my PhD, and then I published some works with Marcelo and Luis Farin and Del Cerro from France, and we extended to 6 and 8 values, and then we extended to first-order logic, and that's, I think that's it. We have some people that's studied LFE, as Henrique said, Omori and the Clay schools with Caniel and Coniglio that started the LFI's logics that has the idea to that we use the operator that separate the factual and fictional values, okay? And some works, that Orland works of fictional values and etc. I think that's enough. And thank you very much.
Thank you very much, Newton and Enrique, for your talks. And then, well, we have time now for some question for both Enrique and Newton. Then I open the session to answer and questions for both authors. If there is somebody have some questions, I don't hear the people in the audience there. We cannot hear you at this moment. I think that is a problem of internet connection, I think. Yeah, now it's better, but I think that is a momentary problem with the internet connection. But now it is we can hear you better.
Maybe now?
Now is much better. Yes. Now is perfect.
I have a question about some specific fiction, like historical novels where all the characters are identified with some actually existed individuals. Is a sentence of such a fiction the factually true or false because of the real individuals involved in it? Or should we introduce the counterpart relation between some real and some fictional individuals to say that names in such a fiction is only homonymical to names of real individuals which are counterparts to them? Is my question correct?
Marcelo, should I answer? I don't know if Newton wants
Yes.
to.
Yes.
Yeah. So we don't have an instance about this. The idea of having immigrant objects in our framework. I would say that the easiest way to go here is to just take all the fictional objects to be native to the fiction. So, like Napoleon has a fictional counterpart. I would say that for the framework we are working with, it would be much easier to to accommodate these cases. But of course, we don't have a philosophical instance on the philosophy of fiction, and maybe our framework could accommodate this view that we have immigrant objects as well. I don't know. I think I didn't answer your question, but we are aware of this issue, and at least as far as I can see, the idea of taking every object to be native is much easier to account for in our framework.
Thank you, Henrique.
Any more questions from the audience? Or from the Zoom participants?
Marcelo,
May I ask a question?
Yes, please.
Okay. I have two questions, an informal one and a formal one. The informal question is, in your semantics, in your models, you have two domains for real and for fictional objects, and intuitively, this it looks like you may talk in your formal language about just one fiction. But what if we want to talk about the real world and two different fictions? It looks like, at first glance, to me, it looks like in this case we would need two fictional domains, each domain for each fiction, and the real domain, of course. Do you agree with this intuitive remark?
Henrique, Newton, do you want to answer?
May you, Henrique, or
No, I would
don't
say
know.
that's a nice suggestion. I mean, we didn't think about having multiple domains, and maybe with more than 4 truth values. But I would say that there's something that could be implemented, and I think that's interesting. I don't know if Newton would have something to say about it.
Well, I think it's a quite interesting question, and maybe I think that model logic will be the best way to deal with that. I mean, like if we take a possibility point of view that each word is a fiction. So we have a natural word that we're talking about real things, and the other words are fictional, and we, of course, we have the problem that if it's the person that in word or the same one in another fictional word, but that's the problem of the possibilities point of view. But I think that's the anyway we think we need some kind of fictional operator, okay, that we are dealing with a sentence in this fictional scenario, and we have like model logic with multiple domains that each word has a different domain. I think the best way to deal with that, but we didn't did that, so it's just a general idea. So it's a quite interesting problem that I don't know if the best way to deal with that, but the way that I can think now and to answer the question.
Thank you. And the other question is about a small technical detail. do you think it would be possible to drop the existence predicate in your formal language and to introduce two types of predicates instead? Sorry, two types of quantifiers instead, for real objects and for fictional objects.
Okay, may I, Newton? I think the problem is maybe we could have some loss of expressive power there, because you could think that in some situations we like to talk in a general way about both fictional and non-fictional individuals. And then if you have two kinds of quantifiers, you wouldn't be able to do that. So I don't have any example in mind, but at least this is something that happens in free logic, because free logic quantifiers range over uh, objects which are assumed to exist according to a Quinian interpretation. So you can express something in positive free logic about empty terms like Pegasus or Santa Claus, but you cannot say something like all works in some story, which maybe don't the characters which don't have names. You can express these general. So I think it could be done, but we'll be worse off. Yeah.
I just think that we have an advantage with respect to
Free logic.
Free logic, yeah, thank you. Because we have the factual operator, so we can say it exists, it does not exist in the sense that it has the predicate without the predicate. Like your example you said, like the real operator exists she's, and she's is something, or it does not, negative of the real operator exists, and exists here is the existential operator, not the existential predicate. So I think that we can use it's a little weird, it's not so beautiful, but I think because we have this advantage, maybe we can abolish the existential predicate, okay? But I'm not sure about it. I think it's intuition. We must make the thing that see that it work, have completeness and things like that. But I think so. I'm not so sure.
Okay, thank you.